Hi all, welcome back. In this video, we're gonna see about the object detection using SSD MobileNet. So SSD is generally called as single shot multi-box detector, which is a popular algorithm in object detection. Besides YOLO, SSD is a better option as we are able to run it on a video and the exactness trade-off is very modest. SSD is a healthier recommendation. However, if the exactness is not too much of disquiet, but if you want to go for a super quick, YOLO will be the best ways to move forward. There are many tutorials are available online to learn more about the YOLO and SSD. Here I am not going much deep into this concept. Instead, we'll see a practical approach on how to detect the objects in live. So let's get started. If you have not watched my previous video on this series, I request you to please watch, because in this video I am going pretty straightforward without talking about the integration and installing of required dependencies. If you want to build an application using this Tensorflow Lite model, it is very important to install the necessary dependencies that we discussed in our previous video. So please watch the video to avoid the complexity while building your application. Okay, our first step towards moving into the code, first we need to add a package, that is a camera package, which I already added over here. You can see this is a package I already added into my pubspec.yaml. You can get it from the pub.dev. You can get this package from there and you can paste it. And along with it, I have added TF-Lite package and as well as a meta package. So if you watch my previous video, you will understand why we have added here. To using a Tensorflow Lite models, we need to add these packages over here. And along with that, I have added the Tensorflow Lite model, which is under assets, which is SSD MobileNet.tf-Lite. Both I have added under my assets folder. So both I have added under my assets. So if you watch my previous video, you will understand why we have added this. These are the necessary and these are the necessary packages that need to be integrated over here. Okay, and we are done with integrating all the necessary packages. Next, we need to go to the lib. Inside lib, I already have a main dot. I have created one sample project. Nothing was there. Just I created one main, and right now I have not created any widgets. Just one simple main. So along with this main.dot file, we need few more classes. Let me add all the necessary classes. So let me create a new classes. One, I need home screen, which is a dot file, and the other one, I need one camera class. So I'll name it as camera.dot, and also I need one bounding, and along with this I also need one bounding class. Name it as bounding box. Okay, we'll see what and all this thing. So for this project, what we are doing is we are detecting object using a live camera. That's the reason I have connected my iPhone. So I have connected my iPhone. If you see, I have connected my iPhone. We are not running in any of the simulator. Instead, we are running in a camera. Why? Because we are detecting the images with a live camera. That's the reason we have added the iPhone to added my device to the Flutter project, and we can build our application into our device directly. This is my main.dot file. So let me build my home screen first. First, go to the home screen here. Let me create a stateful widget. And I'll name it as a home screen. Okay, and I need to import the package, which is material.dot, and here I'll create one constant string, which is SSD. I'll name it as SSD, and here I'll pass a string as SSD MobileNet, which is the name of the model, MobileNet. Okay, fine. Next, inside this, let's create a camera description over here. Just put it from the camera package, cameras. I'll name it as cameras. So just import your camera package over here. Import package. Camera.dot. So this I have imported it. And next, create one constructor for this on screen, and I'll test this dot cameras. Okay, we'll see what and all this. And along with this, let me add a few more things, few more required things over here. Under list, I'll just write a dynamic, and I will name it as recognition. These are all the necessary things which is required in this. So we'll see everything, what and all those things. So I'll write image height and I'll give it as 0, and also image width 0. So here I'll pass my model. Then next what I need to do is, next I'll create one function to load the model. So currently this is the model right now I have, which is SSD MobileNet. This model I need to load it. I need to work this model. First of all I need to load this model. For that, let me create a small function to load my model, which is async. Inside async I'll pass a string as result. I'll write some small switch case. Inside switch I will pass my model case SSD. If the case is SSD, under result I'm going to store await tf Lite dot load model. So in this load model we have two parameters, one is for model and the other one is for the label. So let me write both. First I'll write labels. So in this labels, what I need to do, this is my label. I need to add this label over here, which is inside my assets, and the name is SSD MobileNet.txt, and model. So again under assets I have my model SSD MobileNet.tf Lite. Fine. So I have imported model. So I have let me print my result out of this. Just for seeing what result is printing. That's apart from nothing is there. And after that, so we have created this model. So we'll see how we can use it later. And next, what I need to write is, and inside my container, what I need to do is, I'll remove this container. In place of container, I'll call the scaffold. So inside scaffold, what I need to, I'll create a body. So what I'll write some small ternary operator here. What I'll write, if the model is equals to empty. If the model is empty, what are the passing model? If the model is empty, what I'll do, just I'll not do anything, just I'll pass one small container. Else, if means for the first time when you are loading the project, when you're building the first time, right, at that time if the model is empty, so at that time what I'm doing is I'm just passing a container. I'm just one dummy container. If it is not a container, like if the model is not empty, then I'll create one stack, and we'll see what and all we can pass inside a stack later. Later we can see what and all we can pass inside. So I wrote anything wrong? No, stack, fine. So stack consisting of children, that's okay. The model is sorry, I should pass double equals to. So what it is doing, first time when you're loading this application, at that time it will come here and it will check for the model. If the model is nil, like if there is nothing inside the model, then what it will do, it will just display a small container, and then it will show a dummy one. And otherwise, if the model is not empty, then we will load something inside a stack. That's why we will see what we will load inside a stack. And along with this, and after this, inside the scaffold, after the body, so what I'll do, I want to create a one small floating button. So what I am creating is, if I want to when I create a small floating button over here, when you tap on that particular button, then only we are loading the model and we have start detecting the objects. So for that, let me create one small floating button over here, floating action button, and inside floating action button I'll have on pressed, and inside on pressed I have a child. What I'll do, I'll just simply write one small camera. I'll create one small camera icon. I'll pass icons.photo camera. I'll use some photo camera. Yep, that's all. As of now, I'm not doing anything. I just created my home screen. First, I have created my home screen, and we'll see how we can call this home screen from our main. Go to your main, and previously I have written main, right? Just remove this. So instead we can create, so let me create a camera descriptor because we are referencing from here to home screen. So I'll write camera description cameras. Okay, next I'll write future null. I'll write main async, and inside I write widgets fluttering binding dot mzu initialized. Okay, and after this let me write a try block, try and clash, and here I'll pass the cameras is equals to, I'll check here whether the camera is available or not. Available cameras on. If it is not available, camera exception. If this camera exception, will catch this. I'll print here error. So what I'll do here, solo d dot error code. I just want to print the error code, and along with this I'll print error message too. Dollar d dot message. Right. Okay, I'm done with this. Next, what I need to do is, so let me create one stateless widget because there is nothing over here. We're not doing any setting any state over here, so that's why I can create a stateless widget over here. So, and I'll give it a name as main screen. So let me give the name as main screen. So I will call this from my main. Go down, I will call a run app over here. Inside the run app, let me call it main screen. Okay. And next, here I'll return a material app here. Okay, and inside this I'll call my home. From here I'll call my home screen. Okay. So inside the home screen I have created one constructor, right? So let me call my cameras over here. So you can see when I call this, you see all the necessary things has been added. The camera has been added and the home screen, everything got added, every package is added, and here there is one small camera description is showing as error. So let's resolve this. In white is showing, it's a camera description showing as wrong. Okay, this is not new. Let's remove this new. Okay, it's already there. So then duplication, just remove it. Okay, we are done with this. Nothing is there. Let's run this, and we'll see nothing here. Nothing will happen. We'll run this and we'll see what this will show. Okay, go to your start debugging. Okay, this is started running. Okay, you can see it is successfully installed properly from our main. It has called a home screen over here. Under home screen we have not done anything right now. Only thing is we just added one floating button over here with a phone camera, and we have not given on pressed functions to any of the on. We are not calling any function from our on pressed. It's right now everything is done. So our application is running fine. It has imported all the necessary packages, and the pod is also successfully installed, and we can close it. Let's start building the rest of the code. So there's nothing to do inside our main dot. This is the only thing that we have did in the main dot, and in the home screen. And only thing is we need to do is in the home screen we need to build, and also the camera we need to build. And for the bounding box, no need to worry on creating the bounding box. Bounding box is something like when it detects a particular image, right? It creates a box on that particular image, and it will detect the name and a percentage of its confidence. It will give you the bounding box here. That's already code is there. You don't need to worry on that. Just I already have a code which is already saved. You just copy and simply you can paste it. So there's nothing to do with this. Just copy and paste this. Don't worry, I'll share these project files with you in the description. From those links you can grab these files. Okay, we are done with the bounding box. There's nothing to worry about the bounding box. You can simply get the code. You can just simply copy and paste it. For the bounding box, nothing is there, and for the main also we are done with this. So before doing the before setting up the home screen, let's create a camera for this. Just inside your camera, just write everything what and all is required for the camera. So the camera is a pre-built functionality which is already available from the pubspec.yaml package, which is already available from this package. You just need to integrate the code within your camera. So the first thing, let's create a stateful widget and I'll name it as camera. Okay, and import the necessary packages for the camera, so which is material.dot. okay, and here just type definition void. I'm just creating one callback here, and inside callback I'll dynamic, I'll call list in h, I'll tell you what and all these things in w, and after this go inside your extends methods. So go inside your extends and okay, we are done with this, and after that go to your camera stateful widget, and here just type final. So here just call camera description and just name it as cameras. Okay, and after that call final, call back, and just name it as record emissions. Final string, just call the model, that's all. And okay, just import the camera package here, import package camera / camera dot. Okay, and there's nothing to import over here, there's nothing. Okay, this is okay, there's nothing to do, and what, just create one constructor here for the camera. Just create a small constructor here, and inside camera just pass this dot cameras, this dot model, and also this dot set recognitions. Okay, next go to your extends, and inside just write camera controller. So you hear the what, you are the camera controller that you are initializing it. So this is how you just have, this is what the controller you do, how you do work. This is the controller that you need to work with the camera. So and just create one boolean, so it is detecting, and just initially just pass false. Okay, next, the next important thing, just create one small init state. Okay, so we'll write our implementation inside this init state. Okay, okay, and so okay, we have created a controller, right? Next, for the controller inside your widget, what you need to do is, and before this return, so before you return, write one small condition which is controller, if controller is equals to null. Check if the controller is null, and what you need to do is just controller dot value dot is initialized. Just pass this container inside. Initialized. Okay. So what you have done, if we have checked if the controller is null and if it's not equals to controller.value.is initialized, then what you are doing, we are just returning a container. Okay, next of the implementation we'll see. Okay, now come back to your init.state and inside the init.state, let's create the camera functionality. If widget dot cameras is equals to null, or widget dot cameras dot length less than 1, and else condition. Okay, go inside here. If everything is null, then what you need to print inside is no camera is found. Else go to the controller, is equals to new camera controller. So camera controller inside widget dot cameras of 0, comma resolution preset dot high. So I'll take the camera resolution dot preset dot high. Okay, and next come down, controller dot initialize, then here if not mounted, so what I'll do, I'll simply return. Okay, so I have added the code here, so there's nothing over here, just I have created one controller start image, and inside that I have created this object detection frame. So where it's where I'm just passing a model over here, which is our SSD MobileNet, and width and height of image, and as well as image mean, standard deviation, and what are the threshold value. And along with this, once it gets recognized, I am just showing the end time and detection time and everything, and finally I'm just doing set recognition. This is what the code I have written here. You can get this everything from the project that I have left in the description below, and along with that I have created one dispose. So what I'm doing in our init state, I'm just setting up the camera and then checking whether the camera is available or not. If not, if the camera is not available, I'm just showing this printing, I'm just printing this, and if the camera is available, I'm setting the camera control over here, and along with that, what I'm doing, I'm just detecting an object on frame with the TF-Lite model, and here I'm just passing the model and also the image height and width, and also the mean standard deviation as well as threshold value for recognition. Once it recognizes, I'm just printing the end time and the start time. This is what I have created. Along with that, I have created one dispose function, dispose method. This will permanently remove from the tree. And after that, in our build widget, what I have did is just created one temporary sizes screen width for the temporary controller, and along with them, I'm just passing it to my overflow box. This is what I have done inside my camera. Next, so we are done with setting up the bounding box, camera, and as well as main. Only thing is, we need to pass the data inside our home screen. That's we will see how we can do it. That's only the last step is pending with us, and we'll see how we can do that. And if you see in our home screen, we already did some initial implementation. So we have loaded our model, and as well as we have created a floating button over here that we have seen, and only thing we need to do is we just need to apply the model, and we have to pass the content inside of a stack. To do that, first I have created an on-load model. Next, I need to, once the model is loaded, I need to select the model. For that, let me create one small function which is on select model. Let me write a small function. I'm just creating as a on select model, and I'll pass the model over here, and inside let me write set state, and once inside that set state in this model, I'll just pass currently the selected model. This is what I have created initially. If you remember this, it's currently an empty, and the corrected selected model that store inside here. So this is what on select model I have created here, and after selecting the model, I need to load the model. Here I need to call the load model function over here. So here I'm done with this. Next, I need to call the set recognitions. So let me create a function for the set recognitions, and here inside I'll pass recognitions image height. So if you remember, we have created previously I'll just create a set state inside, and to my recognitions, what I do currently, whatever I'm listening here, I'm just passing here, and also image height, I'll pass my image height here, and also image width. Okay, I'm done with this. And what I need to do in my floating model, so in my floating button, what I need to do, I need to pass on select this I need to call this on select model, I need to call from here. So select model, here I need to pass the model. What is the name of my model? SSD. So if you remember previously, here I have defined a constant sim for this. This is the model, I'm just passing from here on selecting the model. So when it comes here, so currently now the model is SSD, it will go to that load model, and it will check for the case SSD. So why I have created a switch function? If you want to add one more model over here using these cases, you can add the model. That's the reason I have added a switch case over here. I'm just done with this. Next thing is I'm done with now I'm done with floating action button. Only pending thing is my stack. So what, if you remember, initially if the model is empty, I'm just loading a container. If the model is not empty, then we are loading a camera and a bounding box. So here inside we call my camera function, my camera class. To my camera class I need to pass widget dot camera, and also I need to pass my model. If you remember, right, in our camera we have created three things: camera, model, and a recognition. That's only we are passing from here: camera, model, and finally set recognition. Okay, so what is asking? It is showing one error, so I need to import a camera over here. So I have imported a camera. Now it has removed the warnings, and along with the camera, so now I need to pass a bounding box. The bounding box is the one that we have created previously. So inside bounding box I need to pass the sizes, or the sizes in the sense how much size, when it detects a particular person, it's bounding the box over here. For that I need to pass my image max, width and height, and the screen size and everything. And before that, before my scaffold, I need to write this size for the screen. So here I let media query dot of context dot size. So now I get the screen size. So inside my bounding box, what I need to do is I'll check for the recognitions. The recognitions is null, anti array, and otherwise recognitions. Next, math.maths. Okay, I need to import a math here. I need to import math. I need to import math here. Import dot. If you go down, you see math. Yes, math. Okay, I have imported the math here. Just go to here, math dot max, and inside max I need to do two things: math dot max, math dot minimum, and screen dot width, screen dot height, and along with this I need to pass model. Fine, done. So now inside my math dot max I need to pass image width, image width. Inside the minimum, again I need to pass image height, comma, image width. Done. So I'm done with everything. So let's build a project. So I'm done with everything. Let's run the code. Let's start debug. Okay, the application successfully opened over here. There is no issues and nothing over here. If you see the console, okay, everything got detected and everything got successfully installed. Even the pod has installed and everything got successfully installed. Let's close this and we'll see how we're going to detect the images. Let's see how we're going to detect objects. So here in the floating button, so let's tap the floating button, the camera button over here. Okay, you see it start capturing it is predicting everything. It's saying it's a laptop with 71% confidence, and along with that we will predict some more images. I have downloaded it. If you observe this, it's saying like laptop has 66 or 68%, and also if you go down, if you see the keyboard, it is predicting it as 68%, and it is predicting that 50 to 60% as the keyboard is predicting. Along with that, I have downloaded some more images. We'll see. Let's go here. So it has detected as a truck with 68%. So next in the traffic, it is detected in a person with 60% and car with 70%, and it is capturing almost all the vehicles and as well as persons. It's differentiating cars and as well as persons images. So it is okay. So this is how you can detect an object using a SSD MobileNet. So it depends upon your application. You can decide you can decide a cutoff threshold. So we have given the threshold value of your here, right, in the camera. So depends upon your application. You can decide the cutoff threshold below your discard results. If probability is more than 50%, you can consider your object is valid, and whatever your prediction is almost correct. In this way, you can do a object detection using a SSD MobileNet, and which is very easy to integrate. I'll share this project link in the description below. You can go and grab that, and you can start integrating your SSD models into your application, and you can start building your application. That's so easy. Drop your comments in the comment box. If you face any complexity in building this, I'll respond back to your comments. Thank you.